I'm going to talk about virtual file systems. But first of all, my name is James, and I cut code. And I'm basically going to have to apologize for this talk, because what I'm about to show you isn't production quality, but it is quite fun. So there's 3 parts to the talk, and I'll do about 10 minutes on each, and do interrupt, in fact, even heckle, because towards the end it gets a bit silly, but we'll see. So I think I'm going to, in the next half hour or so, tell you about SMB, and SMB 2 and 3, which is a protocol that Windows computers, Microsoft defined it, use when they attach to another file share and they try and look at files and folders. So it's a file sharing protocol. You might have heard of NFS, you might have heard of SMB, or the open source software called Samba, which is a really good implementation of the SMB protocols running on Linux. The other thing I'm going to go into a little bit is how hard it is to implement SMB2. But then I'm going to show you some techniques that basically make it easy because we're coding it on Windows. And I'll explain why we're doing that as well. And by the end of the next half hour, you'll hopefully get an idea of why it's fun to have a virtual file system. And my agenda is to basically really talk about user mode file systems and what they can do. So Fuse, if you've heard of that. So there's 3 parts. We're going to do 10 minutes on, well, network traces really, but yeah, techie stuff on what SMB is. And then 2 demos, 2 sets of demos. The first one is completely open source. You can play with it yourself. The second one is using the same piece of code that's put in a professional product that I've spent the last 20 years building, which is used for film and TV editing and production. And the second one really is out there in terms of what a file system can do. To the extent that I showed the head of storage development in Microsoft, basically a load of kernel devs and there's general manager for storage, some of these demos, and he said he can't do on Windows what you've just done. So I was quite pleased by that. So I'm not a C++ language lawyer at all, and I do apologize if you go and read the code that's open sourced. It's certainly not a quality piece of C++, but it is C++ with a, and I'm very happy to have people contribute and do pull requests. But if we look at the ecosystem that is file systems in user mode, you've got lots of things on Linux, that's great, but in Windows there's a dearth of options. And they're basically all the things that are available to buy or to get open source use kernel mode drivers. And kernel mode drivers for file system redirectors in Windows is basically rocket science, because you've got all these data structures, they change with service packs. You've got to be completely sensitive to where things are, and you get one thing wrong, it blue screens the box. So it's horrible. So I actually know Neil Christensen, who's in charge of their developer API for kernel mode drivers, and I put it to him, it's easier to code SMB2 now than it is to write a file system redirector on Windows. And he agreed. It's actually an easier API than trying to do the official Microsoft way of adding a file system to Windows. Okay. Got a drink. Has anyone heard of SIFs or SMB1? That's a dog, and it's gone. It's left the building, luckily. Microsoft have turned off the SMB1 SIFs redirector by default in Windows 10, thank goodness. Have you ever heard of WannaCry, which was a terrible worm virus that held up the NHS? That was based on exploits in SIFs and MSRPC. So from Vista era onwards, SMB2 is a complete rewrite, and it's really quite an elegant protocol. There are 17 different operations you can do, like you can negotiate a protocol and set things up. You can create a file. If you read the Windows APIs, the actual what goes on the wire is very analogous. So you can sort of get an understanding by reading the Win32 API. But I'm going to put maybe a contentious point. I think Microsoft Windows is probably the best documented piece of software on the planet now. And that's because about 12 years ago, Microsoft lost 2 court cases. They lost a court case in Europe and in America for antitrust practices because they didn't document all the protocols in Windows. The Samba team organized the DOJ and the EU to sue Microsoft. And in response, Microsoft has spent billions of dollars writing, well, tens of thousands of pages of documentation. And so if you want to go and find out how Windows works, you go and read this folder set. It's massive. Must be hundreds of thousands of pages. So one document here, this SMB2, is all the bits on the wire and exactly what they mean and all the semantics. Then it's got another section here, which is all the state machine in Windows and what to do when you get every single piece of logic that might come in. And then there's a third section, which is actually quite entertaining, says me being slightly sad, which are all the exceptions in each of the Windows versions that deviate from the protocol. So it's an exact description of Windows 7 with the service pack, Windows 10 with all the different versions. They bring this out every time there's a new release of Windows. The whole package, every single protocol that Microsoft ships. And I don't think anyone knows about these documents. They're stunning. It's an amazing piece of work. I don't work for Microsoft or anything. It's just that I've been impressed. So I had the idea of trying to write a file system on Windows in user mode. And it turns out with this documentation, it's hard, but it's possible. So that's what we're going to chat about. This talk will be a few slides, but then there will be quite a lot of this sort of stuff too. So we're going to get quite low level and what is an SMB protocol. So on the wire, it's more fun to actually show the tool. So here I've got a little trace of Windows, and I'll zoom in on something. So a negotiate is how you start with SMB. So the client connects using port 445, that's defined in the standard. There's lots of detail I won't go into. I haven't got much time. But basically on the wire, and I'll zoom in for you, this is called Message Analyzer. It's a free tool you can download from Microsoft, and it's baked in. Everything that's in the SMB documentation I just showed you is actually compiled into this tool. So it can crack every single packet on the wire and tell you all of the syntax of what's on the wire. And nicely, if you put your own packets back on the wire, it'll tell you where they're wrong. So it's a huge debugging resource. It's like Wireshark, but it runs on Windows. And the thing it can do, which is amazing, is it can attach to loopback. So most things like Wireshark on Windows can't do localhost because it's a weird redirector optimization, whereas this tool can actually capture off 127001. So basically then, we've got a little thing on the wire. On the wire is actually some bytes. So you've got to, the job is to interpret those bits into that sort of packet, and then to understand the semantics of what's on the wire, and then build your own structures, put them back on the wire, and hope the client agrees that you've got an SMB implementation. So that's all we're doing. It's taken 10 years to write, but that's part of the fun. So basically, the protocol is you negotiate, and there's loads of different flavors of SME2, and this particular response was saying 2.0.2. There's 6 or 7 different flavors of SMB. They're all versioned, and they've come out with Windows releases. But as I said, they bring out this documentation, keep it up to date, so nothing's reverse engineering, nothing's undocumented, which makes it possible. Try and get back to the real slide. Where did I go? Oh, that's because I've confused myself. That's a slide, isn't it? So there's a really, really huge God barrier from this technique working, which is every single packet has to be signed. And the signing code, you're basically coding, you put a damp towel on your head for 3 or 4 days, you code it over and over again, computer says no, it worked, don't touch it. Because it's documented, but it is subtle. But basically, you have to do an MD5 of a HMAC. It's fairly unpleasant. And since Windows 7, there's a demand. It used to be optional to do signing. But basically, they've put in a validate negotiate info as a security feature. And so they've set always this signed flag, which means you have to sign your packets when you make replies back to the SMB client. Otherwise, it says no. It thinks you're doing a denial of service or a man-in-the-middle attack. And so it turns off. So once you've got that bit done, it's actually quite easy. You've just got 17 structures to deal with. You've got lots and lots of detail in each one. But once you've got the signing done, then that's the hard bit done. Oops, no, I don't need to go off. No. Okay, how are we doing? So what we're doing then is we're coding SMB on Windows, because writing a kernel mode drive is really hard. So let's write something in user mode that can do a virtual file system. And the thing about SMB3, the semantics are defined by that documentation. So as long as you obey what it says in the docs, you can do anything. So just because it says it's a file system protocol, you don't have to have files. You've just got to obey the API. So we're going to have some examples of what that can mean. But what I'm really pushing at, I've really built a technique which is RESTful file systems. So if you've heard of REST, you've got these URLs, and URLs can contain state. The text in the URL is a state in your application. You can do that same technique in a folder structure, especially when you've got a virtual file system. Okay. Yippee, got through the slides. So we've got 20 minutes of demos now, so it's much more fun. Oh yes, first off, crash. See, real demos. That's marvelous. Right, I have to go there. Delete him. Oh, yeah. Proper demo-tastic. Let's put them up there. So what we're going to do to start with, there's a bit of open source code, and it's got a number of little example drivers. I'll just show you that. So it's on GitHub. There's a thing that basically has a link to a video. It's about an hour long that goes into excruciating detail about how to build and get into this code base. I'm not going to go anywhere near that. But it just shows you basically how to free port 445, because that's the port you have to bind on to get the protocol to be connected to, and how to set up different things on Windows services. And there's lots of information. And what happens when you first connect is the client does a little chat, like we showed in the message analyzer trace. Right, that's better. So, right, so this example, this file system, we're going to look at some basic Windows command. Yes? No, that's fine. We've got a cunning plan. So there's a command, NetView, and it'll go off to an address and list all the shares. So if I run that on here, I have to run it zoomed out, and then we can zoom in and look at the results. There are a number of shares that my software has just returned, saying, I've got these shares available, sir. What would you like to connect to? So I'm now going to do net use star. Oops. Doing this with glasses on doesn't work. Cool. So I've now got a Y drive, and there's 2 folders in it. I've just connected to the share called sofa. So I've got a piece of Python, and the Python is going to look at particular folders I've got on my C drive that are full of music. I just run that. And it just indexes some MP3s and uses a bit of metadata scraping, and it's putting data into CouchDB. So CouchDB is an open source little NoSQL database. So if I refresh that, I've got a music database that's full of different references to files. So we're looking at how to do virtual folders at this point. We're not going to make up new bytes. We're just going to make up new structures in a folder structure. So if I go back to here and refresh, so now I've got some extra folders. So I've changed something in a database, and I've got a different folder structure in Windows. And if I go and look inside my Bowie collection, I've got a bunch of files. So this is my Y drive presenting files. They're actually stored on my C drive or somewhere else. I'm just mapping the bytes through. So I'm not inventing any new bytes here. I'm just determining how to I won't play the extra music. But this software just sees files and it starts running it. That's fine. So we're playing some music. So what's fun is actually some of these folders I've put some semantic meaning on. So if I go into here, this folder called durations, well, if we look inside it, I've changed the name of things to also include the number of seconds they are in duration. Quite an odd thing to do. If I just do start key equals 200. Now the contents of this is only the songs that are over 200 seconds or more long. So if anyone has ever heard of WinFS, Microsoft spent 5 years with 120 developers, basically spending 600 person years building a database in their kernel mode in Windows so they could do exactly this. This I coded having had quite a lot of gin on a long-haul flight to San Francisco. So 6 hours, 600 years, that's what you get. But that's because user mode's so much easier than kernel mode. And we can just use open source things like CouchDB and do little queries and then see what the results are. So here then, just another example, I've got some files and I've indexed them all by the track number they are on the CD they're in. And so you can just do another sort of query here. Think of a number 1 to 10. So that's all the track number 7s and the CDs I've indexed. Okay, everything I've just shown you is completely open source in that virtual file system repository on GitHub. And what I'm trying to do, I've got an agenda. It's completely free, Apache 2 license. I'm trying to build a community that wants to do user mode file systems on Windows. And I've done the hard bit, but what can we build? Let's go and play. This is just an example, a toy, but it shows you that you can do things in a file system API that you wouldn't expect a file system to do. If I show this to storage developers, they just go, it's evil, it's wrong, which is great. I like that sort of response. Okay. No, I've lost the slides again. That is, oh, that's good. Okay. So I've just shown you virtual folders, folders where we're doing queries to see what's inside them, but I haven't made any bytes up. Yes. So now I'm going to do virtual files, and I am sorry for what it's going to be on camera as well. It's frightening. Right, let's start with some basics. NTFS, you're not allowed to use certain characters. Colon, slash, backslash, because they're keywords in the file system. So let's look at the non-alphanumeric symbols in ASCII. Remove the ones not allowed to use. What have you got left? What can you do with those in Python? Where am I going? Have you got there yet? We'll see. So I've got an example now. This isn't open source because what I'm going to do is boot some software which I've helped write. And then we're going to do bad things. Got to turn him off. So this product, it's used for finishing films. I'm not selling it, but it is for sale. It's made by Grass Valley, a Belden brand. See, it's done my advertising. And loads of films. If you ever see stereoscopic films, there's lots of quite famous films have been through this code base, which is fairly frightening. Anyway, here I've just got a very simple 1-minute clip on my timeline. I hate typing on demos. I'm just going to do it here. Right, so what I'm going to do, look at this. MS Paint is normal Windows shipping MS Paint. I'm going to go to localhost, a share called Quantel. And then there's their weird folder, compose, semicolon, timeline bracket. Oops. So that bitmap did not exist before I ran that command. What's he doing? So we can, yeah, so 1220 is the frame number, and bitmap is a type, is a MIME type. So I've got a JPEG. The JPEG's much littler because it's optimized for building thumbnails for websites. But I want a bigger version. I don't know, let's try that. So I've just coded the sizer in our video editor to size the picture before I make the JPEG. So do you get what I'm doing? I've got an SMB server. It's connected into my video editor on port 445, and I'm following paths that code what I want. I've inverted the control. File systems, normally the server's in charge. Now I'm the client telling the server what I want. I'm demanding. A reasonable man gets up in the morning and conforms their behavior to people's expectations. The unreasonable man gets up in the morning and demands the world changes to meet their expectations. I didn't make that up, someone else did. Right, okay. So did you spot there were some brackets? So what's here? That timeline is a function call. So everything compose semicolon is saying load the Python file compose.py, and then we eval the string that follows it. So sat is a little function in Python, which is going to take the timeline, it returns a clip object, and apply a saturation of 0 to the payload, and then it asks for a different frame as a bitmap. And it's made the image black and white. So we can change the nature of the bytes we're offering by using Python as a little domain-specific language. Oops, yeah. Right. Now, what I told you is I come out of video. So there's a file format called MXF, which is a bit like MOV or MP4, but it's used in professional broadcast BBC type things. And this is VLC, completely unchanged off the shelf, and I've just made my 1-minute timeline appear as if it were an MXF file to VLC. And I can whiz around in it. Yeah, it's normal playing a video. So if we take this idea, I'm going to run with it until we really run out of juice. But there's only a few more strings to do. But so what are we doing here? See if I can zoom in a bit. So I've shortened the functions. So timeline is the same function as T. And I've got another function here, S. It's not the same as sat, I'm afraid. But basically, it's saying subclip. So I've got a 1-minute clip, and I'd like a part of that timeline as a shorter file. I'm just asking for 8 seconds of material. So now I've suddenly made an 8-second file instead of a 1-minute file because I'm just using that function, the DSL, to adjust the object model in my C++ using Python to interpret it. Okay. So we can do a bit more. Because I said we've got all these lovely characters in ASCII to play with in these files. So now, in fact, I should have allowed you to zoom in. So what I'm trying to do here is I'm taking a list of different subclips and composing them together. So I'm editing now. So instead of subclipping, as well as subclipping, I'm editing together. This is an example of an idea. I'm not advocating this. It's got huge security holes because I could put any Python in here, like os.rmdir or something, and it would just get evaled, and you'd have an interesting day. The other thing that's fun, the SMB protocol. I know Windows says it's got a 256-byte limit, but the protocol says there's a 16-bit integer, so unsigned. So you can put 64K of payload in this path. So you can do quite a lot of damage with that. But we're programmers, so we don't want to do great big long strings if we can do loops. So here then, we've got a little for loop for 100 times. What's it going to do? Is it going to work? So I've now made something that's 6 minutes 40. It's 4-second segment that's repeated 100 times. So I'm editing video in my file system. What's really quite fun, the code base I'm running has actually got a mapping onto CUDA because it does really big pictures for film. So I believe this is the only file system in the world that's coded on GPU. quite fun. It was only an accident, but it does actually have a GPU path through if you've got the right hardware. So it can do pretty big pictures uncompressed in real time. Cool. Right, I'm now going to do the last thing, which is super naughty in terms of demos. It turns out that that constraint you had with those 8, 9 characters, colon, slash, that's an NTFS constraint. It's nothing to do with SMB. And Matthew George, who's the kernel implementer of Windows for the SMB redirector, doesn't look. He said, no, you can use any character you like. So if you look in here, there's a colon in my file path. I'm doing a little range, whatever. What's that called in Python? I'm not very good. What's that? A slice. We're going to do a slice in a file system. Yes. We've just put a colon through a file system path. Just fun. So you can't do that on Windows, can you? Top. Okay. Didn't crash. Sorry. Where have we got to? So, it's short and sweet. It's a bon bouche, hopefully. It's hopefully shown you that you can do things with file systems that are different. There's some source code you can play with. And I really think it's quite fun playing with user mode file systems. You can do things that are a bit out there. And okay, I'm not advocating putting Python in file path parsers in production quality secure systems. That would be challenging, but it just shows you what you can do. So I've got a little bit of time left. I don't want to overrun. Have you got any questions, or are you just going to throw rocks at me? Hello. So the actual code that does the RAM out of the networking, there's no mem copies in that path. I've optimized it. So I can run full out on a 10 gig network, and it's like 9.7 gigabits on the wire. So there's nothing in the way, as long as the drivers you've written are instant. So if you've got your RAM, your bytes prepared in RAM, then it will go on the wire speed. And also, we've got a project at work which is starting to use RDMA. And there's a mapping of SMB onto our RDMA. So a little fantasy project I've got is actually getting it to work on RDMA over FCOE. But that's out there, sorry. But yeah, no, it's fast. It's not a problem. The hardest thing is actually getting the bytes ready for read. I've optimized the read and write paths. DIRs and things are slower. Oh, go for it. Oh yeah, that's right. No, so it's a good question. The question was, to free up port 445, surely you have to turn off loads of Windows, the Windows subsystem. That is a way to do it, but actually I've got a little tool which I gave to the Samba team. It's called Free 445, and it cuts the link between the whole SMB and Windows subsystem and just port 445, and then the driver frees it up. So it doesn't turn off any of the Windows subsystem. It just stops the server offering the port 445 binding. So the client all works completely, so I can go surfing off from this machine to lots of other things, but I can no longer serve SMB requests other than through my code. But some of the calls I'm making to do things like that authentication, I'm using Windows APIs to do, and that's all working still. And it can still be domain joined and all sorts of stuff. So that's all still there in this technique. It's a lot easier than kernel mode, blue screens and all. Any more questions? That's it. You've got completely bamboozled. I think we're done. Alrighty.